Transversals and angles. There's a lot of vocabulary in this section, so I want to take a closer look at these angles in action. So here we've got a pair of parallel lines. I and G are parallel. And you can see this dot, it says slide me, right? So I'm going to keep this angle measure the same, and I'm just going to slide it along this other line called a transversal. So I slide it up to the next intersection, and I can see that this is also the same angle measure. So this is the first pair of angles that we're going to look at that are congruent in this drawing, and these are called corresponding angles. Now, when it says spin me, so when I spin this around, I can see that this also has the same measure, which you may have predicted because this angle and this angle are vertical angles, right? So we know that they have the same measure. But that also means that this angle and our original angle have the same measure. These are called alternate interior angles. They get their name because when we look at this transversal, one's on the left, one's on the right, one's on top, the other's on the bottom, right? So they're alternate in their position. Then they're called interior because they're inside the parallel lines. Okay, so these are alternate interior and they are congruent. So far we have three types of angles. We have, if I go back, we have this one and this one, which are corresponding. Then this angle and this angle, which are vertical. And then this angle and this angle, which are alternate interior angles. So here's a drawing similar to the one that we just looked at. Let's see if we can pick out the corresponding angles first. So corresponding angles, remember that was the one that I started with and I just slid along the transversal. So it looks like if I take angle A and I were to slide it down along the transversal, it would line up right on angle E. So angle A is congruent to angle E. Let's look for another pair. B, if I slide B down along the transversal, it will land on F. So angle B is congruent to angle F. There are two more pairs of corresponding angles. We've got C and G. And lastly, D and H. The next type are alternate interior angles. Remember, those are the ones that we looked at that are on opposite sides of the transversal, but inside the parallel lines. So an example of that, inside the parallel lines means we're looking at these four angles. Remember, one's on the left and one's on the right, one's on the top, one's on the bottom, right? They're alternate in every way in their position. So that would be C, which is top left, and F, which is bottom right. So angle C is congruent to angle F. All right, let's look at the other pair of alternate interior angles. We have D and E, right? D is top right, E is bottom left. So angle D is congruent to angle E. Now, this one, actually, had to fix a typo there because the next type is alternate exterior. We didn't look at those in the diagram, but as you would expect, they're alternate, just like these are, right? One's on the left, one's on the right, one's on the top, one's on the bottom, but they are outside the parallel lines. So that means I'm looking at A and B and G and H, right? So alternate exterior, we've got two pairs. We've got angle A and angle H. And we've got angle B and angle G. And the reason that those are congruent, I mean, it makes sense if you think about it, because we know that C is congruent to F, right? Because they're alternate interior. But B and C have the same measure, and so do F and G. So it would make sense that B and G would be congruent. All right, we've got 2 more different types of angles to look at. So the next one you're probably more familiar with than the rest of them, and that's vertical angles. So that means that angles that are opposite each other, right? So we've got a lot of them. We've got 4 pairs. We've got angle A and angle D. We've got angle B and angle C. And then angle E and angle H. And lastly, angle F and angle G. Okay, we're almost there. The last type that we're going to look at, we did not look at on the diagram, but let's talk about what angles in this diagram would be supplementary. So let's start by looking at corresponding angles, right? We know that A and E are one example of corresponding angles in this diagram. We also know that if you take angle A and you add it to angle C, that equals 180 degrees, right? A plus C equals 180. But if A and E are the same thing, the same number, then that would mean that E plus C would also equal 180. So we have a name for these angles. They are inside the parallel lines, if you look for C and E, right? They are inside these parallel lines, but they are on the same side of the transversal. So they have a very fitting name. They're called same side interior angles. So they're all supplementary. Same side interior angles are supplementary for this reason, right? So we've got angle, well, we can write measure of angle E plus the measure of angle C equals 180. And then we've got a pair on the other side. Measure of angle D plus measure of angle F also equals 180. And then we've got a whole lot of linear pair angles in this picture, right? Linear pair means they make a straight line. So we've got A plus B equals 180, right? And A plus C, and F plus H, and E plus F, and E plus G, right? All of these angles that are next to each other that form a straight line are also supplementary angles. We're going to use that newfound knowledge of these congruent angles, and we're going to find all the missing angle measures in this drawing. So we have 2 angle measures to start with, and we're also given some information that you may have overlooked. Do you see these little arrows on the lines? Those arrows mean that those segments are parallel, right? So this line up here is parallel to this line down here. And although it looks different than what we just saw, this line here, this segment, acts as a transversal. So let's start with that transversal. If you look at this transversal, we have alternate interior angles because this angle is on the top and it's on the right of the transversal. This angle is on the left and it's on the bottom and on the left of the transversal. So that means that these angles are alternate interior, which means that this missing angle measure must also be 44 degrees. The same thing is going to happen when we look at that 37-degree angle. See if you can figure out which angle is an alternate interior angle with the 37-degree angle. So this one is inside the parallel lines, right? Because you can extend these parallel lines if it makes it easier to see, to make it look like the other drawing. these lines would continue and these lines could continue as well. But we're still dealing with the same situation of parallel lines with a line going through them. And that line that goes through them is called a transversal. So this transversal this part of the transversal is in between these two parallel lines, this one and this one. So we've got 37, which is on the left side of the transversal and up on the top. We've got this blank angle measure, which is on the right side of the transversal, and it's on the bottom. So they are also congruent. They are alternate interior angles. That only leaves one angle left in our triangle, right? But we know that the three angles of a triangle must add up to 180. So let's see what we've got so far. We've got 44 plus 37. So that gives me 11, 81. So what number would I add to 81 to get 180? Well, you could do it in your head. If it were 80, that would be 180, right? But it's 81, so I have one more than 80, so I need one less than 100. So this has got to be 99. Now, if all of that talking through it, doing it mentally was not your style, then you could also do the subtraction, 180 minus 81, and get 99 that way. Okay? All right, so one angle left. If this angle is 99 degrees, then this one must also be 99 degrees because they're vertical angles. All right, so we used alternate interior angles here and here, alternate interior angles here and here. Then we knew that the triangle sum was 180, so we subtracted these two angles from 180 to get 99. And then we could have done that in the other triangle too, right? Because we had the same situation in both. Let's look at what happens when we have two triangles that have all the same angle measures. These two triangles have all congruent angles. And what I mean when I say that is, if you look how they're marked, this has just one arc, and so does this angle, which means those two angles are congruent. This has two arcs, and so does this one, which means that those two angles are congruent. And like we just saw in the last problem, if we know these two angle measures and we add them together and subtract from 180 to get this measure, it's going to be the same thing that we're going to get for this measure, right? If we add the same two numbers and subtract from 180. So all three of these angle measures are congruent to all three of these angle measures. So these two triangles have congruent angles, or they're congruent to each other. So right now, I'm going to do a series of transformations to show the relationship between these two triangles, right? So I'm doing a translation first, and this translation, once I do a translation, we know that this new white triangle is congruent to my original white triangle, right? Because a translation is a rigid transformation. It keeps the shape congruent. Right, now I'm going to do a rotation, just a slight rotation to line them up. So again, a rotation is another rigid transformation. So right now this new pink triangle is congruent to the one I started with. And then the last thing I'm going to do is a dilation. So I'm shrinking the triangle, but notice that the angles are still the same measure, right? I'm just making the side lengths shorter. And now I have the smaller pink triangle. So I did two rigid transformations, which kept the triangle congruent to what I started with. And then I did a dilation. And you remember what happens when we do a dilation. We end up with a figure that may be a different size, but it's similar, which means that the shape is preserved, right? Same shape, different size. So when you do a dilation, you end up with a similar figure. So if we come back to these two triangles, we know that these three angle measures are congruent to these three angle measures because we did that in the last problem. So what's the best description of the relationship between these two triangles? They're similar, right? It's just a rotation, which keeps it congruent, and then a dilation, which creates a similar figure. And the last geometric property that we're going to look at is the measure of an exterior angle of a triangle. So you can see that we have this triangle and that each side length of the triangle has been extended in just one direction, right? So that creates three exterior angles. We've got an exterior angle here that's labeled, but we also have one here that's not labeled, and we have one here that's not labeled. But I want to show you a really interesting relationship between the exterior angle and these two colored in angles. These two colored in angles in relation to this one are called remote interior angles. Remote because they are the farthest away, right? This angle in the triangle is right next to it, so that's adjacent. But the other two are farther away, so they are remote. They're interior because they're inside the triangle, right? So we've got this exterior angle here and these two remote interior angles here. I'm going to pull this slider. I'm going to do it kind of slowly so you can see what's happening. So we're translating this angle, right? And we know that when we translate, right, we preserve that congruence. Now this green angle is going to rotate out, which rotations also preserve congruence, and then it's going to slide along this line. And look at that. When you put those two remote interior angles together, they're the same size as the exterior angle. So we can use that to problem solve, right? I'm going to do it one more time just so you can see it again. So the pink angle translates over, the green angle rotates and then translates, and then you can see that when they come together, they're the same size as that one exterior angle. All right, time to put this to good use. So if the measure of angle 1 is 70, and the measure of angle 4 is 135, find the measure of angle 2. Now, some of you might be thinking, oh, well, if this is 135, I can find this. Yeah, you could, but you don't need it. If you're asked to find the measure of angle 2, you don't need to find the measure of angle 3. It's not asking you for that right now. So what we can use is our remote interior angles theorem. So we know that these two, angle 1 and angle 2, are remote interior angles with angle 4. So that means that these two angles add up to equal the same thing as this angle. So if I had to write an equation, I could write measure of angle 1 plus x equals the measure of angle 4, and x being, what I'm looking for, right? So I can fill in with numbers now. So I know that the measure of angle 1 is 70. So 70 plus something is going to equal 135, right? That's my setup. I know that these two added together will equal this one. So I can solve this equation. I can subtract 70 from both sides. And I get that x is equal to 65 degrees. So the measure of angle 2 is 65 degrees. Now I know some of you are looking at this thinking, yeah, I just did 135 minus 70. Do I have to write the equation? No. Only if you're asked to show an equation that models this. But if you're not, then it's enough to just know in your head that you have to do 135 minus 70 to get the measure of angle 2.